In ancient history, creating software involved a lot of manual labor. We would invoke compilers by hand, run tar on a bunch of class files or other compilation products. More sophisticated engineers might have used make to wire it all up in a fancy, brittle makefile. Maybe some of us still do. But yeah, I find that is a lot of manual labor. So the IDE, the Integrated Development Environment, would offer an interface for the whole software development lifecycle, from editing, formatting, refactoring, building, running, testing, debugging, packaging, deploying, and also offer a structured environment to structure your code in projects and modules. I'm Justin. I work on such an IDE on the IntelliJ plugin for Scala. And I will tell you about how we're going forward to integrate developer experiences with the build server protocol. I put a few links here to Slido. So if you enter sli.do/sphere-it and then go to the ScalaSphere room, you can ask questions at any time and we'll address them at the end. Also our Twitter, we have a team Twitter, IntelliJ Scala, and I have a personal Twitter, Ebenwert. So if you have questions or less productive comments, you can direct them at me on Twitter. That's what it's for. I'd just like to do a quick poll at this point. Who uses IntelliJ for Scala primarily for their code editing? Yeah, that's still a lot of you. And by the way, who knows that a lot of our code is on GitHub, like free, open source, Apache licensed? Great, that's many. Now everyone should know, right? So, also several of our team are here, Pavel and Alexander, who used to be the team lead. Anyway, so IDEs, great stuff, all in one tool, but a lot of us like working with tools that do one job, do it well, you know, Unix philosophy, and can be used in a variety of contexts, like build tools, dependency managers, test frameworks, and can be used on your CI pipeline, on your desktop, or wherever you like on different operating systems. But that has a different challenge now again. We're not using our integrated tool. So what we've done traditionally is try to write custom integrations if we have a popular tool to make this usable from the IDE front end. As you can see here, there's a bit of a mismatch in the APIs, in the user interface, if you want. Yeah, those are faces. They don't fit together. We've done some custom integrations in the IntelliJ Scala plugin specifically for Scala test specs, like test frameworks, for SBT, which I have been working on a lot, for akka, play, Scala format. And other tools likewise have to repeat this kind of effort for integrating with specific tools, like Bloop, which is a compile server. I'll talk a bit more about it later. Has custom integrations for SBT, Mill, Maven, and a variety of build tools. Variety of build tools. In Scala, we have plenty of them. So, yeah, there's little coherence in how we work with them, because they all have their own idiosyncratic API. But I just want to use my favorite front end, of course, IntelliJ, because I don't want to switch context between IDE and shell or some other editor maybe, and have so many manual steps in my workflow. I just want to edit code and get compile errors, or maybe not compile errors. So we have a bit of a haphazard tangle of tools. And I've been trying to untangle this a bit and tie the loose ends of tooling together to create a more integrated developer experience. But first, some prior art. There's been various protocols, attempts to integrate tools by protocols. A very successful one has been the language server protocol by Microsoft. It was designed to facilitate integrating compilers, typically with the VS Code editor. So it's been actually so successful that people have been asking us if we're going to use it to integrate with Dotty. I used to say no, but actually maybe, or at least for a while until we get something better. But usually in IntelliJ, like with various frameworks and tools, we rely on custom language integration. So we write our own parser and type checker, for instance, to highlight errors, to allow refactorings, and all that. Basically, most of the features you use in the IDE depend on our own implementation of a abstract syntax tree that gets updated while you type. So using LSP to integrate with the IDE has some challenges. So there, for instance, it doesn't model the structure of a code base. It's just a workspace and a bunch of directories. While in IntelliJ, we have a project model that we use for actually building and resolving scopes and whatnot. LSP outsources this to a language server. But that doesn't work so perfectly for us. In LSP, there's no common concept of building your project. It's just implicit. If you change code, your build language server will recompile. But we would sometimes like to be able to manually trigger a recompile or even rebuild the whole project. And we can't do anything smart with LSP beyond that what a language server offers. So because it does not expose a model of the syntax tree. So there's that. Now I mentioned a variety of build tools. Scala developers are pretty unhappy with theirs, so every few months or so someone comes out with a new one. John today showed some tricks with his new tool, Fury, which is hopefully going to be publicly released soon. So here's Fury emerging from the sands. Now, Fury doesn't really have users yet, so I can't justify a full-fledged support as we have for SPT, because I'm still fixing bugs in that. And it has a user base of approximately 1. Nice. So one solution to this is that the tool author supplies some custom support for their build tool in the IDE in form of an IDE plugin, or maybe just an IDE export as Mill originally did, which may or may not stay up to date with how the IDE specifically works. But I want to open Fury projects in IntelliJ, so So I'm just going to go ahead and do that here. Fury, if you can read this. And it opened, of course, on my other screen. Here's Fury. And you can see there's all this code, and I can navigate around, and so the thing seems to be imported correctly. So how was this done? By implementing build server protocol in Fury. So implementing this manually might have cost me maybe a few days, maybe a few weeks, depending. But I was inspired by Abraham Lincoln, or whoever gave this quote: "Give me 6 hours to fell a tree, and I will spend four of them sharpening the axe." And I thought, yeah, give me 1 month to support a build tool, and we'll spend a year developing a protocol. So that was Fury. By the way, Fury is a bit special because it's both a build tool client and a build server protocol server. So relative to the IDE, it acts as a server, but it also acts as a client relative to Bloop. So if you haven't heard of it, Bloop is a compile server, which is also a build server protocol server implementation, but it doesn't do the whole build tool shenanigans such as generating code or such. It focuses really just on compiling or running tests and applications. So Fury actually generates Bloop configuration files and asks Bloop to compile the code based on the Fury model, and then forwards the messages to the client eventually. So what is this build server protocol? Going by the name, you can already guess it's kind of related to the language server protocol. It actually extends and complements it. It's based on the same JSON RPC basis. You could theoretically implement it together in a single server. There are, however, some minor differences in how you do a handshake and, of course, what operations you can do. What it tries to do is abstract the project model into a few generic concepts that I'm going to talk about shortly, and give a few common operations on those. So some base concepts. It's a client-server protocol. However, it's bidirectional, so both the client and server can send requests to each other. But typically, it will be the client that sends a request and the server that sends a reply. But there's also the concept of a notification, which is a simple one-way message. And usually, it's the server that sends notifications. Now, I showed you that I can open a Fury project in IntelliJ, but the question remains, how does IntelliJ know how to talk to Fury? Like, where's the server? For that, we made up this server discovery protocol, and it simply goes like this. The server, when you install it or initialize it for a project, will write a connection file either in your project directory or to a specific user directory, like in your local user local share BSP server JSON. And the client will look in these specified locations for this connection file, and this connection file will describe how to start a server. The client starts the server and communicates with it over standard in, standard out, as simple as it gets. So once it's got that, we can do some requests, like lifecycle requests. So initially, this client will send to the server a request build initialize, and the server will eventually reply, and once it's actually done, send a notification, build initialized. Then all the interesting stuff happens, and eventually there's a request to shut down and exit. Now the interesting stuff. This is our build structure model. So in most build tools have some kind of model for structuring your code into modules or projects or targets. So in SBT it's projects, in IntelliJ it's modules. In BSP we decided to just use the name target. Target is associated with a bunch of capabilities, like you can compile it, you can test it, and some language-specific data. So you assume a target is maybe a Scala target or a Kotlin target. And a target can have dependencies, and by these dependencies are dependencies on other targets. And that's pretty much it. Then we have in a separate request, we can request the sources. Sources can be associated with one or more targets. And likewise, one target can have multiple sets of sources. Then there's some common actions, such as compiling, testing, running. That's things we usually want to do with our code. So we hard-coded, hard-defined these actions into the protocol. So a typical flow will look like this. The client sends to the server a build target compile for a bunch of targets. These hexagons are the targets, so they're in the request. Then stuff happens, and eventually there's a compile result. Stuff happening are diagnostics and progress notifications. Diagnostics is the LSP word that we copied for compile messages, so typically warnings and errors, or sometimes just random information that may or may not be useful to you. So these get sent as notifications from the server to the client. Usually they're associated with a compile request, but they might happen at any time in principle. And we have progress notifications or tasks. These give updates on what's currently happening, because a compile is often a long-running process and with lots of sub-processes, so you want to know how far is it going. These may also be sent independently, but typically are triggered by a request. And I'm going to show you a short demo of how that looks. Where's my IntelliJ? Over here. I'll close Fury because it doesn't work that well with Fury yet, but we'll fix that soon. Instead, I'll open Akka, which I have exported to Bloop from SBT and then imported into IntelliJ, and trigger a build. So, where's my build tool window? This one. So maybe you can see what's going on here, despite the low resolution. I somehow triggered 2 builds, but that's fine. So you see here, build is running, and there's a second counter for how long it's been running, and here you already see some subtasks. So it compiled Akka protobuf in 3 milliseconds, and it's currently compiling Akka actor, and it doesn't seem to be progressing that well, so maybe there's some bug going on here, which is unfortunate. But I hope you still get the idea. So IntelliJ Scala client supports BSP, as you've seen now. Since 2.19.2, it's basically an official feature. It mostly works. The protocol might still have a few updates that we want to do on it, but that's very minor. And so currently it only supports Scala targets, but we want to increase that very soon to other languages like Java and Kotlin, and also increase expand the scope of the build tool support from just Scala build tools to others. So like I've just today been talking to some Bazel developers about this. So also Pants might be supporting it soon. Now I want to go into a little fun thing, how the build server protocol gets imported into IntelliJ. So we have up here a build tool, SPT. SPT has one type of project model, namely it subdivides projects into projects, which can have multiple scopes, various dimensions of scopes, but most commonly we use compile and test. And these are within one project. In BSP, we don't have scopes, we just have targets. So what we do when we export to BSP, or like the Bloop model, we map one scope in SPT to a BSP target, which shares some metadata, so we can say they belong together or they have some dependency on each other. In IntelliJ, on the other hand, we have scopes, but only a limited number of scopes, compile and test. And we have another limitation, namely that modules can't share source directories, whereas in SPT or BSP, targets or projects can share source directories. So what we do here is we do some hackery, BSP target that is compile scoped and one that is test scoped get mapped back into a single IntelliJ module. We might consider changing this because it causes problems. But if you have a shared source, then that gets mapped into a special synthetic module, and the modules that depend on this shared source depend instead on this shared module. That kind of works, but not really, because as soon as these targets have conflicting dependencies, so not module dependencies, but compile dependencies like jar dependencies. You can either find out a way to switch between them, which we don't really support in IntelliJ at the moment, at least, or you can just dump them all into one scope and then start exploding things. But at least you get to edit it. One way around it might be support on the build tool side, but that's not really nice. But we're looking at how to do this better in future. I've already showed you how a compile request looks. Let's see if IntelliJ, no, this just completely broke. That's great. Yeah. I always find the best bugs during presentations. But this is how it looks in the end. If there's like warnings, if there's warnings, you'll see a nice list of warnings here, and you'll see how long each target took to compile. So that's a bit more than vanilla SPT or IntelliJ will give you at the moment. Now we already have a whole ecosystem of tools that work with BSP. So on the client side, we have IntelliJ, of course, but also Metals. And we work with various servers. So Fury has a native implementation of BSP, and Bloop, which was like the original BSP server implementation. Bloop, in turn, works with all these other build tools, SBT, Maven, Gradle, Pants, and Mill. You can export their model to a Bloop model, and then Bloop acts as BSP server. So that's a little bit roundabout, but in some cases you might decide it's worth it if the improved incremental compilation of Bloop speeds up your productivity. And in the lower right corner here we have, like, with lower opacity, Bazel and Pants, where we're currently considering working on getting something started. Mill is a bit cut out there because we already have an open pull request on the Mill that implements BSP natively for Mill. So, bit of a roadmap of BSP. So the protocol is basically final at this point. We have these server and client implementations building on this version of the protocol, and more tools are incoming. What we want to do over the next months maybe is support BSP in the IntelliJ base distribution, so that you won't have a dependency on the Scala plugin, so you could use it with any build tool potentially, and more languages. And of course, we'll work on improving the robustness of project mapping and testing, and oh yeah, we have support for test requests as well over BSP. So if you have test support in the build tool but not in the IDE, you can run it over BSP. So what this enables is not only various public build tools, but also build tools that are local to your organization or even your project, because your project has very special needs. You have a special build tool. You can use BSP, support BSP, and will get IDE support for almost free. Now I wanted to take a look beyond what's beyond a build server protocol. So it's basically an effort of standardization and way to integrate more tools with each other. So you can consider what kind of tasks are worth making a protocol for, because there are so many different implementations and you'd like them to work together. So some ideas I've had are like linting or more fine-grained testing than even BSP offers, or maybe remote building could be part of BSP. If you have other ideas, go to the Slido/FearIT, like, comment, and subscribe. No, just comment. And we might be able to discuss them later. Of course, a challenge here, actually, I think the major challenge is adoption, which is one reason I'm talking here to you, so to raise awareness. Another one is if the tools are similar enough to each other to warrant this abstraction, because it is a bit of a lock-in to certain ways of doing things. So once the slides are for download, you'll have some links here to the BSP specification, implementations, libraries, test kit, and a blog post that I wrote which summarizes this talk basically. Now that concludes this presentation. Here's the links. So please go to Slido, rate, comment, subscribe, and all hate to Twitter, please.
So thank you very much.
Thank you. Okay, question.
Yeah, we have a question on Slido. Can BSP be tightly integrated with LSP, so highlighting we can get from BSP by compiling at the same moment?
So, if I understand this right, can we get highlighting over compiling by BSP? In principle, yes. Like in Metals, exactly. So that's what Metals does. Metals doesn't do its own compiling. It outsources this to Bloop via BSP and just forwards the diagnostics to the editor. We've looked at this for Scala 3 and with LSP, and in principle we could also do this in IntelliJ. That has the advantage of that we actually get the errors that the compiler emits and not some approximation thereof. But the disadvantage that we don't have the full information that we have in the IntelliJ editor. We don't have the full AST, so we can't do nice stuff like smart type diffs, for instance. Or, yeah.
Okay, so I guess there are no more questions then.
Oh yeah, there's a manual question.
Suppose I use some obscure language which doesn't even run on Debian, and I want to provide basic support to BSP. Which methods are absolutely required so that IntelliJ can at least support the project and compile it?
Well, there's a bunch of methods. We can go through them offline because explaining this right now would be too much. So but it's not super complicated, so in a simple version you might implement this in a few hours. Yeah. Any other comments? No? Okay, then. Thank you for staying here. I declared this a closing keynote. That's the advantage of getting the last talk. So, thank you for attending my closing keynote.
Thank you very much. And I also want to thank you all for coming today to the Sphere IT conference and the ScalaSphere.
We have another question.
Oh.
Yeah, can BSP also provide project structure? Yes, that's a major part of what it does. It defines a way to provide the project structure.